Hello everyone, welcome to the video lecture series of Internet of Things. In today's lecture, we are going to discuss topic IoT at a glance and history of IoT. I am Professor Swati Suresh Pawar. Before starting with today's lecture content, let us revise the contents of the previous lecture. In previous lecture, we have discussed enabling technologies in IoT. Now let us discuss IoT at a glance. History of IoT. IoT came into the world with the initial effort of Auto ID Research Center from MIT, that is Massachusetts Institute of Technology, when they worked on how to uniquely identify an object in the open world. With the help of RFID, they came up with the Electronic Product Code, that is EPC, which is designed to be stored on RFID tag to provide unique identification for a product. Thing or object can be referred as a real-world entity that can be connected to the communication channel in some way to obtain surrounding data and process it into useful information. IoT targets connecting the real-world smart entities like smartphones, PDAs, laptops, etc. and even things living and non-living that doesn't have any processing capacity like tables, fridge, ships, dogs, etc. to the digital world. The characteristic IoT tends to provide are the 5As and 3Is, that is, 5As are anything, anywhere, anytime, anyway, anyhow, and 3Is refer to the instrumented, interconnected, and intelligent. IoT-based devices, objects refer to 3Is to provide services to the user in 5A manner. Information and Communication Technology, that is ICT system, used to generate, gather and process data manually before the inception of IoT, but IoT-based system enhance this feature to be done automatically. That is machine-generated data and cloud-based storage and processing without human supervision. Object Name Service is a mechanism to find out information about a product and services from EPC. ONS is a request that returns the list of all network accessible service related to the requested EPC. ONS takes EPC as an input parameter and provides address of EPCIS as an output in the form of URL. ONS doesn't contain the actual data of EPC but the address of services where actual data resides. ONS acts as a directory that routes the EPC information from requester to destination node. About things in IoT. IoT tries to connect multiple objects together that gather data and enables them to generate useful information via communication network. Objects or things are the core part of the IoT system. IoT devices can send and receive data directly or indirectly and also has ability to process it to information. Some things are able to process complex data while some are only able to sense a single entity. Things can be real or virtual nodes and has varied computational capacity. This processing can be done locally, remotely using centralized server or can use a cloud-based application platform for the same. IoT device can process the data as per its memory, processor, speed, communication, etc. If processing requires higher specification, IoT infrastructure can provide the same. IoT devices can pull together data from attached or onboard sensor, for example, IR sensor, temperature, humidity sensor, etc. and can process data locally or can forward the data to higher power devices or cloud-based applications. IoT devices and actuators can be connected together so that IoT device can communicate with other physical entities, maybe IoT based or some IoT based system. For example, a relay connection to a small electric circuit in the house can control the applications like light, fan, AC, etc. over the internet. There are various types of IoT devices available in the market like sensor, LED lights, smartwatches, wearable sensor, automobile parts, etc. One main feature of things is each thing has unique identity and an identifier that separate out individual thing in a widespread network of devices. RFID tag, sensor and actuators are used with the animate, that is living, and inanimate, that is non-living object to make these things part of the IoT system. Animate objects can be people, animal, groups, cells, DNA, etc. Inanimate things can be moving like vehicle, packages, mobile phones, laptops, PDAs, etc. and fixed like machines, poster, industrial plants, building, etc. Objects connected via sensor, actuators and RFID tag have limitations of energy, processing power and storage capacity. This wide array of objects is created by various manufacturers which rely on the separate technologies. Interconnection and interoperability of these devices is a major issue. Which protocol needs to be used in which layer of IoT is a crucial decision for communication of these devices. The identities in IoT. IoT-based system has plenty of devices throughout the network. An important feature of these devices is that it has a unique identity and an identifier that separates out individual things in a widespread network of devices. IoT things must have unique identity to operate in the IoT network. Various identification mechanisms are available globally. This addressing capabilities provides the mean communication endpoint to these devices. Various mechanisms are used for such identification, that is RFID, NFC, ONS, IPv4, IPv6, EPC global, etc. Maintaining these identities is a challenge in the IoT. IPv4 and IPv6 are frequently used for addressing of objects which are connected over the network. IPv4 provides 32-bit addresses while IPv4 provides 128-bit address mechanism. IPv6 has longer pool of address compared to the IPv4. IP-based identification mechanism has limitation of this address length. These addresses are used for routing the messages into the network for device-to-device communication, but IP addresses can change based on the location. That is, PC might change IP address based on network it is connected to. Identifiers are more like a name, which remains constant regardless the change in location of the device. In IoT, RFID tags are usually used for identification of the devices, that is living, non-living, moving or fixed, and remain constant with respect to change in locations. Identifiers can be used for various applications, from basic identification of a product in a grocery store to checking whether the food in the package is edible or not. IETF, that is Internet Engineers Task Force, and IRTF, that is Internet Research Task Force, has come up with the modification to the IP address mechanism, which is Host Identity Protocol, that is HIP. HIP performs identification part of IP mechanisms, and addresses on only be used for routing of packets on a network. Electronic Product Code, that is EPC, commercialized as EPC Global, is designed to be stored on RFID tag to provide unique identification for a product. Object Name Service is a mechanism to find out information about the product and services from EPC. The working of ONS is similar to DNS in the networking. ONS system has root ONS and local ONS. Root ONS keep the IP address of local ONS and local ONS keep the addresses of the EPCIS. About the Internet in IoT, communication from the backbone of the IoT-based system, managing all the data transfer from one device to another device or device to a central collector. Communication technology is divided into two major types, that is wireless and the wired, or we can say wireline. Nowadays, Internet and World Wide Web, that is WWW, terms are used as if they represent the same things. But Internet exists long before WWW. Internet terminology is used to represent the vast network of interconnected computers distributed all over the world. Internet refers to the actual connection, that is wired or wireless, or a path from one computer or resources to other. Internet forms the backbone network of the platform on which the whole IoT systems are developed, while WWW is the method to access the internet with the help of hypertext transfer protocol, that is HTTP, using address or link like www.abcde.extension. HTTP is one of the many protocols available to access resources available on the internet. Internet can be considered as a huge container containing parts like www, emails, FTP, P2P, chat, telnet, etc. Internet and WWW are treated as if they are interchangeable, but it's not so. WWW can be considered as the most popular method in Internet. To give a general example, consider Internet is a restaurant and WWW is the most popular dish of that restaurant. Web of Things provides a way to implement Internet of Things by integrating the web, that is application layer, and internet, that is network layer. Figure shows the internet and its part, World Wide Web, that is WWW, email, chats, P2P, FTP. Internet Protocol Suite. IP stack contains physical layer, network layer, transport layer, and application layer. The physical layer manages the interconnection of nodes and hosts in the network. Protocols in this layer operates only on the links. Ethernet, LAN are some examples of the physical layer. The network layer, that is internet layer, manages sending of packets across multiple networks. Routing of packets from source node to destination node happens in a layer, for example, ICMP, IP, IGMP, etc. The transport layer maintains end-to-end communication throughout the network. It also provides flow control, retransmission of packets, multiplexing, etc. For example, TCP, UDP. The application layer manages application data exchange over the connection established by following layers, for example, HTTP, FTP, POP3, SMTP, SNMP, etc. Figure shows the Internet Protocol Suite. First is application layer, which consists of FTP, HTTP, DHCP, SNMP. Then transport, TCP and UDP protocol. Network layer consists of IGRP, IGMP, ICMP, ARP, IP, RARP. Physical layer consists of IEEE 802.3 Ethernet. IoT framework. IoT system can be classified based on the services it is providing. M2M, SCADA, RFID and WSN are the four pillars of the IoT. IoT framework can be thoroughly explained by machine to machine, that is M2M pillar of IoT. M2M uses smart devices or objects to detect events and transfer it to other central devices, that is usually of higher processing capacity, which translates such sense data to meaningful information. M2M connectivity considers cellular network for its communication. M2M works on GPRS, cellular and fixed network, which makes the M2M functionality more popular in the USA compared to IoT. M2M refers to products, services and device connectivity technology provided by cellular wireless network, which are operated by telecom companies. There are some consumers electronic services in place which follows M2M approach. M2M includes telematics, that is long distance transmission of data and the information, and telemetry, that is reading and transmitting the same data from devices. As shown in the figure, middleware placed on the server side is the backbone of M2M architecture. Figure shows the IoT framework using M2M architecture. At the bottom of this architecture are the smart objects. These can be consumer electronic devices like the fridge, AC, vending machine, etc. or considerably small devices such as pet collar for pet tracker, personal medical devices, personal tracker, etc. These objects can be accessed remotely using M2M framework. The next layer provides the communication and network solution for the smart devices deployed in the below layer. This layer consists of wired and or wireless network adapters which are managed by Gateway Manager software. For accessing the smart devices remotely, device-specified protocols are used. The next layer is the brain of the whole M2M, which is middleware. Middleware uses M2M specific communication protocol to collect data from the gateway, for example, network, and process it into useful information using business intelligence. Middleware also provides a platform to the developers for application development. It provides software and API support for application development. Because of middleware, developers don't need to worry about the data gathering and communication mechanism from smart devices to the middleware. The top layer, which is the application layer, is accessible to the user. It provides a platform to the user to access smart devices remotely at touch of the fingerprint. Mostly the applications developed are used to connect and communicate between devices personalized for spec verticals. Examples where IoT framework can be used: application for the cellular M2M. Applications of cellular M2M. First is medical, transport, industry, home automation, and automobile. Medical. Wireless medical device can be used for remote patient monitoring. Transport. Traffic control system can use device to monitor traffic scenarios and regulate it efficiently. Industry. Industrial automation of manufacturing process can help improve productivity and cost efficiency. Home automation. Alarm and surveillance devices can be used for tracking and anti-theft alarm system. Automobile. Specially designed devices can be used for tracking and anti-theft alarm system. Advertising. Remote management of digital billboard can be updated remotely. IoT and M2M. Communication protocol. How the communication happen between machines and device can be the differentiating criteria for M2M and IoT. M2M primarily target non-IP based protocols like Zigbee, IEEE 802.15.4, 6 LOWPAN, Z-Web, etc. IoT mostly uses protocol like COAP, HTTP, MQTT, AMQP, WebSocket, etc. M2M focuses on protocols in network layer and below. IoT uses mostly protocols above network layer, that is in transport and application layer. Things in IoT versus machine in M2M. Things in IoT refers to an IoT device with a unique identity that has a capability of sensing, monitoring and actuating. IoT systems are made up of heterogeneous things like sensor, actuators, and have software components for communication and computation power. On contrary to above M2M, usually is made up of homogeneous devices, and most like devices like mobile phones, PDAs, etc. have software component inbuilt. Hardware and software aspect. IoT system has specialized software that maintain the gathering data from the sensor, compute the data and convert it into the useful information, and how this data is communicated to the cloud-based platform for further processing. Thus, IoT focuses more on the software part. M2M emphasis is given on hardware devices as the core network, and communication technology uses homogeneous entities for developing M2M applications. Data collection and analysis. IoT applications has a very powerful entity which is cloud-based service. IoT uses private, public or hybrid cloud for storing and intense data analysis, which is usually not possible on limited things. M2M data gathering is done on point-to-point, that is device-to-device basis, which is usually done locally. Only in premises, databases are used for storage of M2M gathered data and processed information. Application aspects. As cloud platform is used in case of IoT application development, IoT application covers a massive and real-time data, that is information management. IoT application covers enterprise management, intense data analysis applications, remote information management. High-end data analysis tools and frameworks are available with the help of cloud-based services. M2M focuses in the building application and scope of MCN is limited compared to equivalent IoT applications. M2M network and scope is limited, due to which the MCM application development is on premise. Summary of today's lecture. In today's lecture, we have discussed IoT at a glance, history of IoT, IoT framework, IoT and M2M. Thank you.